Hello, year 10s. So you've got through quite a bit of your forces booklet now, and we're just going to move on to Newton's second law. So if you just scroll down here to around about page 25, what you'll see is just before the required practical that we did in class before we broke up, you'll see Newton's laws. So you need to read through this and pay specific attention to Newton's second law. And that says that the acceleration of an object is directly proportional to the force applied. The acceleration of an object is also inversely proportional to the mass of an object. So basically what this is saying is that if you take an object like a box, a crate here, and if you push it with a big force, it will accelerate at a large rate. If you push it with a small force, it will accelerate with a small rate, much lesser rate. What it also says is that if you increase the mass, it will accelerate less. So the bigger the mass, the less the acceleration. The smaller the mass, the more the acceleration. So it's inversely proportional. When the mass gets bigger, acceleration gets less, and vice versa. So this is the sheet that we're just going to do a few examples from. So you should have that at the ready. And okay. I'm just going to do a few of these. Okay, so what we've got then is you've got to give the term symbol in units for acceleration, force, and mass. What we're going to do is just do question number 2. We'll do question number 2A. And it says to work out the force, so you box force, and then you underline, in the case of question A, 4 kilograms. So mass is equal to 4 kilograms. Acceleration A is equal to 2 meters per second squared. Write down your formula. Insert your numbers. 4 times 2, and it's equal to 8. Now, force is measured in newtons, so it's 8 newtons. Okay. Now, okay, question number 5. Question number 5. There's a 50 kilogram skater pushed by a friend accelerates 5 meters per second squared. How much force did the friend apply? So, force is equal to, we don't know. We do know that the mass is equal to 50 kilograms and the acceleration is equal to 5 meters per second squared. So force is equal to MA. That's equal to 50 times 5. So 5 lots of 50 is 250. So newtons. Okay. Right, and moving on. Question number 8. So question number 8 asks us to work out the mass in each of the following. So we'll just do question 8A. So 8A, so mass is equal to, we don't know, but we do know that we've got acceleration equal to 5 meters per second squared. The force F is equal to 12 newtons. So write down my formula, F equals MA, insert. So I've got 12 is equal to M times A, which is 5. I want to make M the subject, so I divide through by 5. I divide both sides by 5, and it will cancel the 5 on the right hand side, and that will leave me with 12 divided by 5 is equal to M. So M is going to be equal to 12 divided by 5, which is going to be 2.4 kilograms. Okay, so with a hard one, let's just number 12. Okay, now number 12. A force of 20 newtons acts on a 500 gram block. Calculate the acceleration. So we are calculating the acceleration. We're given 20 newtons and 500 grams. So acceleration, we don't know. But we do know force is equal to 20 newtons and the mass is equal to 500 grams. Now, if you know on all these questions, I always write down the units. Mass is measured in kilograms, so I need to convert this to kilograms. So in order to do that, go from grams to kilograms. I divide by 1,000, which will leave me with 0.5 kilograms here. A common mistake, it's often overlooked in exam questions. You see 500 and just multiply it by 500, but you need to divide it by 1,000 to get it in kilograms. So now we've got formula. F is equal to MA. Now we insert 20 is equal to 0.5 times A. I want to make A the subject, so I divide through by 0.5. So I've got 20 divided by 0.5 is equal to A. So 20 divided by 0.5 is equal to 40. So A is equal to 40 meters